Hi guys, it's your guy Holumde, and today we're going to be considering another one of the most commonly asked DSA interview questions in top tech companies that include Google, Amazon, Meta, Netflix, and Spotify, and the rest of them. We'll be treating the reverse linked list problem, and the problem statement is simple. It says reverse a singly linked list. So we described in our previous video, a singly linked list is a list, a linked list that consists of a node, its value, and the reference to the next node. So now we want to reverse it, just like we can see in this example given 1 2 3 7 3. These are the node 1 2 4 7 3. These are the node, and we are reversing it to become 3 7 4 2 1, and we are doing this in place. To solve this problem, we can think of storing the values in the linked list in an array. So since the value at each node is a number, we can store it inside an array as 1 2 3, and we have an array of 1 2 4 7 and 3. So, and then we can reconstruct the linked list by transversing the array in reverse order. So we can do it, and we can reconstruct the linked in by transversing the array in reverse order. So in the sense that, okay, if we find the reverse of this array particularly, we can have its reverse, and then we will now use it to create a new linked list. So by reversing the array, we have this, and we can use this to construct a new linked list in reverse. So but doing this will actually create a new linked list object. So what we want to do actually is to modify this existing linked list in place, so that we reverse it in place, not creating a new one. So let's try to do it in place. A key observation here is that if we flip this arrow, if we flip the direction of the linked list, we are going to be efficiently getting a reverse linked list. By flipping the arrow of 3 to 7, 7 to 4, 4 to 2, and 2 to 1, we are effectively reversing the linked list. So what we need now is just to figure out how to perform the pointer manipulation. Let's consider an example on how to do this. In this example, to reverse all the pointers, as reversing the pointers is going to give us a reverse linked list, and to do that we will need to iterate through the nodes in this linked list, and in each process we are going to get the current node and the previous node, and we are going to take the current node, the next attribute of the current node. Instead of referencing the next node, let's take for example the next attribute originally references this node here, node 3, but now we are going to take the next attribute to reference the previous node. That's why we'll be needing two nodes in this one. We'll be needing the previous node and the current node, because the current node have a next attribute that is referencing the next node, but we need to reverse it, so it's going to start referencing the previous node. So if we look at it, starting from the first node, as we are going to be iterating through each of the node, we see that the first node has a next node, but it doesn't have a previous node. So the previous node will be set to null or none, depending on the language. So because it is the first node, it does not have a previous node. So we are going to set it to none, and here it is. We have this null, so it's going to represent our previous node, and we have this current node, which signifies the start of our linked list. So now we have this null that will represent the previous node to the first node, which we used to call the head node. is the head node, so the node that we initially have access to generally. So, and then because it's the first node, we are going to create a we are going to let our previous node to represent just a null. So now we are going to make the current node next attribute, which originally referenced node 2, is going to reference the previous node, which is this null node now. So right here we have shifted the next, we replaced the next of our current node here, which is originally referencing the node 2, is going to be reversed to reference the previous node, which is none. And now we need to reverse the next node. Now we need to reverse the next pointer, and to reverse the next pointer, which is this particular pointer right here, pointer 2, we need to find a way to shift our previous node to become here at this node 1, and to shift our current node to become node 2, so that whatsoever node 2 is referencing, which is 3, we are going to change it back so it can reference 1 as well. So that way the pointer at node 2 will be reversed to node 1. However, to shift the previous node now, we can set it to the position of the current node. So it has been shifted by 1 so it moves now from null to node 1. So but to shift this current node, we actually have lost reference to it, because we have made the current node, which is node 1, to reference null in reverse, because we are trying to move them to reverse. So, and by that we have lost reference to node 2. This means that we should have preserved the reference to node 2 before reversing the pointer from node 2 to node 1. So before, the pointer actually points from node 1 to node 2 before, and because we are trying to reverse it in place, we shift it to point from node 1 to node null. So, but we should have actually reserved this reference to node 2, so that this current node can move 1 bit to the node 2 and it will not lose reference. And because of that, what we are going to do is that we are going to set a variable next node equals to current node dot next, meaning that just before we move our pointer and we shift current node next attribute, which means the pointer from the node 1 here, which is originally pointing at 2, just before we move it to null in reverse, we are going to define a variable that we collect, that we reference this particular node 2, that is the immediate original pointer of node 1. So we are going to collect it, and this is it visually here. So that way now we have a reference to the original next pointer, and whenever we want to, after reversing the pointer for node 1 to null, we want to transverse the array to the next pointer to reverse it also, from 2. Instead of pointing to 3 now, we want to point it to 1. You understand? So, and in doing that, we will set our previous node to the current node. So, the current node is originally here, and then our previous node is going to move from null to the current node, and we will set our current node also here, which is originally here before. We are going to set it to the next node. Don't forget that we have kept a reference to node 2, our next node here. So we are going to set it there. So note that we don't need to shift our next node after setting it here. By the time we are traversing the array to moving the previous node to the current node and current node to the next node, we don't really need to shift the next node. Why? Because in the next loop, you understand, we are going to be setting the next node to this immediate current node, which is node 2. So the next of node 2, which is node 3, we are going to be setting our next node to it. So instead of moving it here, we don't need to move it. So in the next loop now, just like in this particular loop, we've moved from null to 1 and from 1 to 2. So the current next of this current node is now node 3, and then that will be our next node that we are going to register as our next node, while we now take the node 2 and make it to point to node 1 in reverse by setting our current node dot next equals to previous node, like we explained here. So we are going to set it to the previous node so that it could reference node 1, and then after doing that we want to proceed to the next node, and what's the next node is actually node 3. So we can summarize this logic into 3 steps. We iterate through the linked list, and at each node in the linked list, starting from the first node, which is the head node, node 1, we are going to save a reference to the next node. So saving a reference to the next node means we are saving a reference to node 2. Why? Because we are about to change the next attribute of this node to the previous node. You understand? So we need to keep a reference to the next node. So because this one is about to change to the previous node, and that reference we need it when we are trying to move on to the next node in the linked list. Don't forget that a linked list cannot be indexed. So we need a reference to it. We cannot index it. So, and that's why we need to keep reference to the next node, and after that we change the next pointer, the next attribute of the current node, to reference the previous node. So at first we know that we are starting with 1, so it will be null. So it's going to reference null at first, because 1, which is the head of the linked list, does not have a previous node or previous pointer. So, and then the next thing after making it to reference the previous node is that the third one is that we are gonna move the previous node and the current node forward by 1. And what it means is that we are gonna set our previous node to our current node. You understand why? Because the previous node is 1 step back. So we're gonna set to our current node, and we're gonna set our current node to our next node that we have kept reference of. You understand? So, and that's what we do. And what we do is that, at this point now, it is in a new, they are both previous node has been shifted by 1, current node has been shifted by 1. So what we want to do again is do this loop again. So it's gonna be a recursion. We are gonna take the next node again, and we are gonna define a next node variable that we collect the next of the new current node. Don't forget, current node has been shifted from 1 to 2, and now the next attribute of the current node, which is 3, we are going to take it and make it into this attribute. We are going to save it as a variable, and the next thing we are going to do is that we are going to take this this current node, which is currently 2, so its next node we are going to shift it to 1. You understand? And how do we do that? We say that current node dot next equals to previous node, and after doing that we are going to take the current node and the previous node and shift it by 1 by moving our previous node from 1 to 2 and moving our current node from 2 to 3, which is referenced by the next node. And we are going to do that over and over until this current node gets to null. Don't forget that once current node go away from this now, and we are able to shift the reference of this 3 to 2, and then we move our previous node to 3 from 2 and our current node to none. Why? Because this is the last node, so the next node is going to be a null. So it's going to be a null. So it's going to be a null here. So, and once it is null, we are going to end the loop. So that's how we're going to be solving this problem. Now let's go into the code implementation of the linked list reversal. Let's call the function linked list reversal. Let's call it this function now, and it's gonna be taking the head node. Don't forget the first head node of our list node, and it's also gonna be returning a list node. What we call a list node is actually a class that we're gonna define now. Let's still pass out of this. So a list node is a class that will describe how our linked list is gonna look, how each node of our linked list is gonna be. So you can just take it as each pair of, or let me say each single node in the linked list is going to be represented by list node. So, and then in the initialization of the function, we'll be giving it some values, one thing that is common, two things are common to a node. It is the value and the next. Next means that a reference to the next node in the linked list. So, and what we want to do is that we'll be setting it as the value, and similarly we'll be saving or storing the next, which is the reference, as the next attribute. So those are the two attributes we need for basically for a node. And head is a node. Head, don't forget, head is the first node in a linked list. So now we define our class list node that represent the node. So I take it as an habit to define what we'll be needing at first. So looking into the structure, we have node 1, node 2, node 4, node 7, node 3, as we can see in the previous diagram in the Canva. We have this node 1, node 2, node 4, node 7, node 3, and node 1 have a nest of node 2, node 2 have a nest of node 4, node 4 have a nest of node 7, and node 7 have a nest of node 3, and therefore we need to be able to place a none on this place, because you know that the last node will not have any nest, so it has to be set to none by default, so signifying that that's the end of the linked list. So fine, and now that we have our node 1, since node 1 is the head node, node 1 will be passed to the function linked list reversal. So node 1 is the head node. So, and that's it. So let's continue now. I love doing something like so that we know what we are working with. So let's define, like we say in the in our code, in our logic, we define the previous node and the current node. So don't forget, the previous node will be set to none. Why? Because starting from the head node, which is our current node now, is the beginning of the of our linked list. So the previous node to the head node is none. Why? Because there does not exist any previous node. So fine, that's how we set previous node to none and head node to current node to head. So while current node, why I'm saying while current node is because you see current node and previous node will be moved. It's like we are iterating through or traversing through, don't let me say iterate, we are traversing through the array. So moving from the head node to the next. So it will get to a point whereby we will get to the end. That's how we say wow. So in a situation whereby current node does not reference a node, is now referencing none, that is, we know definitely we've gotten to node 3 and we there's no need to go any longer. So that's how it's placed the while current node. And what we want to do is that, don't forget the 3 logic we discussed. The first thing is to collect the next node, assign the next node to be current node dot next. So meaning that we are keeping track of the next reference to the current node. And what we want to do now is that we want to also take the current node next currently and want to set it to the previous node. That's the way we can that's the way we reverse, by setting it to the previous node. And the next thing now is to traverse to the front by setting our previous node to our current node and then setting our current node to our next node. So that way it keeps traversing. So as simple as that. After that we return our previous node. You might be wondering that why are we returning previous node. So why we are returning previous node is that this loop keep going until current node becomes none, because of while loop we stop when it false. So when current node move from 3, it will move to none. Why? Because the next of 3 is none. It's none that you are seeing here, and because of that current node will drop, the while loop will break, and at that point previous node will be currently at current node. You understand? Don't forget that current node will move to none, but previous node will retain the position of the current node, which is the last node. However, you understand? And then that's just it. So that's it. And when we run the code, when we print it, see, printing it is actually going to return the previous node here. So which, when we print it, gives us this. You understand? It's going to give us an object. So but to really identify it, we need to print .val, so that we print the value attribute of this particular list node. that is returned, and then it's gonna print 3, just like we can see here. So, and it print the correct answer because 3 is the, it has been reversed. 3 was the last, but now 3 is the first now, and you will see 3 pointing to 7, 7 pointing to 4, 4 pointing to 2, and 2 pointing to 1. So okay, let's print it that exact way. Let's print it that exact way. Let's write a function that will print it. Def print linked list. So this function is gonna take in an head, which is the reversed head, you don't forget, and then it will be a list node object, and still gonna return a list node object. So, and what we do is that we collect that head. Don't forget, we'll be passing in previous node to it because we want to print it in a printable format, not just printing the value or object. So what we want to do is that while head, so while head, let's define a variable that will be collecting it. Let's say string, the character equals to, no, let's say character, let's say s, let's call it string s, that we collect the string. So let's say s is empty, and what we're gonna do is that we say s plus equals to string concatenation. So head dot value, so let me say string of, so that it can convert it to string even if it's a number. String dot value, and plus, so I want to put this direction there. So this direction is actually going to just make it formatted in a nice way. So, and then we're gonna return x. So instead of printing directly, we're gonna use this function to print it. So print linked list of this. So let's see how it goes. Okay, let's write a function that will print it, so we can see that it has really reversed the linked list. So we are gonna call the function print linked list. So it will take in head, which will be the head that is it will be this previous node that is returned from this one. Why? Because we just want to give a visualization, like a display. So it will also be a list node, and the return is gonna be a list node as well. And then what we do is that we are gonna define a string that will be concatenating each node. It will be adding them up. And while head, so what we wanna do is that we want to do this some concatenation s plus equals to head dot value. So it will take the value and add it with this formatting, to add this formatting. So what we're just trying to do is that we've solved the problem, but I want to print it in a format that will be much more, that you really see that the linked lists have been modified and have been modified in place. So after doing this, we say head equals to head dot next, so that it move on to the next node. And after this, we can now return our s. So this way, instead of printing this one here, we are just gonna come here to print, apply this one, print linked list. So why you are putting print in front is because don't forget that print linked list is a function that will return s, so we have to print that string s. So let's remove this value now, so it's deal with node. So running this function, you know, it is a dot value. The value of our node is actually a number, so we have to convert it into a string. I realized that, so let's rerun it. So you see it has been printed 737421. You see it has been printed in reverse, which is initially 12473. So that's how we solve this problem, the reverse linked list. Simple like that. Just follow the logic, and I hope you understand. Thank you.